Picture a Danish field lined with solar panels. In that setting, the world's first commercial e-methanol is being produced. Could this new fuel be a turning point for global shipping?
Today is May 25th, 2025. Let's dive straight in. Denmark just launched the Kasso Power-to-X facility, the first commercial-scale producer of e-methanol. Why is this significant?
It's significant because shipping moves about 80% of global trade and is responsible for roughly 3% of greenhouse gas emissions. Clean alternatives have been out of reach for such a large sector, until now. This plant in Abenraa produces 42,000 tons of carbon-neutral e-methanol every year. It uses local solar power, green hydrogen, and biogenic CO2. This isn't just a demonstration, it's actual industrial output.
Let's unpack the process. They start with water and use electricity from a 304 megawatt solar park next door to split it, right? That gives them green hydrogen.
That's right. Then they bring in CO2 captured from nearby biogas plants and waste streams. Combine that with the hydrogen, and you get e-methanol with up to 97% fewer emissions than fossil-based methanol. The key is how it's integrated with existing supply chains. This isn't theoretical. It's already being delivered to customers.
And those first customers are major players. Maersk is fueling the Laura Maersk, the first container ship made from ethanol. Lego is using it for plastics. Novo Nordisk is reducing its supply chain emissions. Why are these companies leading the way?
They all face pressure to decarbonize. E-methanol fits into their current operations without huge changes. For shipping, it's a near drop-in replacement. For manufacturers, it substitutes fossil methanol in plastics. For pharma, it cuts emissions tied to logistics.
A plant produced its first 5 tons back in March 2025. It's also the first methanol site certified under the EU's Renewable Fuels of Non-Biological Origin Framework, RFNBO. How critical is that certification?
It's essential. Certification means the fuel meets strict sustainability rules. That opens the door for regulatory support and market access throughout the EU. Without it, scaling up or exporting would be much harder.
Let's pause on a term we've heard a lot: hard to abate. Shipping and heavy industry get this label. Is it just about energy needs?
That's part of it. Ships are on the move for weeks, crossing oceans. Batteries can't provide that level of energy. Current technology just isn't there. Fossil fuels have been the default until now. E-methanol works with most of the existing infrastructure and engines, with only minor changes.
Okay, but scaling up isn't guaranteed. What would it take to make enough e-methanol for all global shipping?
Several factors. First, a huge supply of renewable energy, usually solar or wind, close to the e-methanol plant. You also need efficient electrolysis and carbon capture at scale, ideally sourcing CO2 from various places. Modular plant designs help speed things up. And long-term demand is crucial, often secured by contracts with shippers and manufacturers.
International cooperation seems vital. You need to standardize production, agree on sustainability, and get the financials right. Who actually drives this?
Regulators like the EU and the International Maritime Organization set the standards, but it's the partnerships among energy firms, shippers, and manufacturers that really make change happen. Financial incentives can help offset the higher initial costs, especially for infrastructure upgrades.
So this Danish plant, is it just a one-off, or could it really have a global effect?
It's more than a one-off. It's proof that large-scale e-methanol production can work. If Denmark can do it, other countries can follow. And it's not limited to shipping. Sectors like steel and chemicals could use this model too.
Still, there are open questions. Can e-methanol get cheaper? Will infrastructure keep up? How fast will policies adapt?
Those are exactly the challenges ahead. But now there's finally a working example to learn from. That's a shift, from debating ideas to actually seeing them in practice.
To recap, Denmark's Kasso plant links renewable energy, green hydrogen, and carbon capture to make e-methanol. It's already being used by ships and manufacturers, and it's certified. This model could change how we move goods and make products around the world.
And that's the real significance. It matters not just for Denmark, but for the global economy and for tackling climate change.
Thanks for joining us as we tracked the rise of e-methanol and explored its impact on shipping, industry, and the planet.
Thank you for listening. This episode was brought to you by mynews.studio. Try it free today.